Welcome to Taxonomy Online Mathematics. Today we want to take a topic under calculus. So we take the introduction part of it, which is the limit of a function. So let's start with the explanation. Now we say that the limit of a function at any given point A, so the given point can be any variable in its domain, is the value that the function approaches as its argument approaches A. Now this is just given mathematically as lim, that is limit of any function. This is used as a function as the argument, that is the value of the independent variable, the x, approaches a particular number. And that particular number at this time is what we are calling what? The A is going to be equals to L. And the L is our limit. The limit of the function. The final point of the function. If we have the independent variable is taken to approach a certain number. Now, so if for example, we are saying that this function is a function is given as 1 over x, where in this case our x is the independent variable. Now if you want to find the limit of this function, then let's say x taking some variables. Let's say x taking, assuming variables as 0, positive values, 2, 3, continuous. If I am taking the x to be for a value like 0, it means 1 over 0, and that will be undefined. It means that 0 cannot be part of the values of x. That is, they are saying that the values will be in its domain. It means 0 is not part of the domain of this function. All other numbers, either above 0 or below 0, can be values that the s can assume. So it means 0 is not part of the domain. Okay, so we want to see what will be the various limits that we can get. So if I use this, it means 1 over 1, I get 1. If I've taken this, it becomes 1 over 2, and that gives me 0.5. Let's go step further. 1 over 3, that will give us, I think, 0.3333 recurring. Now let's go further to say that we can take more values of x. Let me take values of x to be 10. So that is going to give us 0.1. If I have 1 over 100, meaning the x is 100, I'll be having 0.01. Let me also say that, let me take the last one to be 1000. It means I'll be having 0.001. I believe you can see the pattern that we have 1 being bigger than 0.5. 0.5 being bigger than 0.33. 0.3 being bigger than what? 0.1. If I have moved from here to 4, you'll have seen that 1 over 4 will be 0.2. So from 1, 0.5, 0.3, 0.2, 0.1, 0.01, 0.001. It means if I've taken a number between 1000 and 10,000, I'll be having 0.000. So you can see that as this number is increasing, as the values of x is increasing, the limit of the function or the values of the function is also approaching 0. It's not 0, but it's approaching the values of 0 because it's decreasing. So you can see from here, we are getting closer. If I'm to approximate this to only one decimal place, 0.0. So I have this 0. So it means that as the values of this get bigger and bigger, which we can also say that bigger and bigger simply means as the values of x is approaching infinity, meaning I'm putting a very large number, the values of the function will also continue to be getting closer to 0. That's what the definition said. So as we assume a particular number of the argument, then we are going to get a value of the function getting closer to a certain number. So that simply means that the limit of the function, this, which in this case I can write its value 1 over x, as x approaches infinity, is just going to be what? 0. So this means that 0 is the limit of this function. So the limit of a function is always taken to show what to be the limit point. Don't forget we have the left side of the limit and the right side of the limit. Meaning the number we assume from 1 going. You could also get below. So if we are taking below numbers, then you also get the upper limit and the lower limit. Alright, let's bring another illustration. Let's say we have the function given to us as 1 over 2 exponent n. This is a function. So if, okay, let me use the x so that I'll have it there. If this is the function, now if I begin to put values of x to be equals to 1, this time around, let me take it a step bigger than the one we did. So if I put 1 here, I'll be having 1 over 2. So 1 over 2. If I put this one here, having 1 over 2 exponent 10. And I believe that will be 10 to 4, something like that. Then you're going to have 1 over 2 exponent 100. And you know, in fraction, if your denominator is increasing or is big, it means that the values you are going to get to be having more zeros before a significant number. So if I say I have 1 over, let's say 2, the answer I will get is 0.5. If I increase this to 1 over 10, I'll be getting 0.1. So if I increase this, the numbers will be having more zeros before a significant figure. So this also implies that as the values of x is increasing, approaching infinity, then the function will also be getting closer to 0. So the limit, the function, in the beginning we said that we represent the limit function as equals to L, where the L is our limit we're referring to. So that simply means that this function, if this x is approaching infinity, the function that we have as 1 over 2 exponent x will also give us what? 0. So the limit of this function will give us as we are having out there. All right. Okay. What if you want to find the limit of a polynomial function? The limit of a polynomial function. Now, we know polynomial functions are values of degrees. We can have x plus 1. We can have 2x squared plus x plus 1. If you want to find the limit of this, so for example, if I have a function equals to 3x plus 1, I have to know the limit to this function. So let's say as x approaches what? 1. As x approaches 1, it means that as the value of x is approaching 1, the value of x in the function will assume 1. So it means this is going to be, let me write it like this, limit of 3x plus 1 as x approaches 1 will become 3x, and the x is assuming a value of what? 1 plus 1. So if I multiply this, I'm going to have 3 plus 1, and that will give me what? 4. So the limit of a polynomial is that the argument is going to replace the values of x. So if I have so many values of x, the argument will be taking 8 places. So if the x is having, let's say, I have a function equals to 5x squared plus x minus what? 10. Ask x approaching 2. If I have this function, no, don't forget we can write it as a limit, as in this form. If this is the function, if as x is approaching 2, it means that whenever I see x, it takes the argument of what? 2. So here we are going to have 5x, and the x is what? 2. Exponent 2 plus x, which is 2 minus 10. So right away we know this is going to be 2 multiplied itself 2 times. So 4. 4 times this, 20 plus 2 minus what? 10. I believe this will give us 22. Minus this we have for 12. So it means that if you are having any polynomial function at all, then there is no cause for alarm. What do you want to do? Just put in the value of x, the limit given to you. Place it or substitute it into the equation, then perform your operation. Then, oh yeah, you are there. So for the next one will be the limit of rational function, but that will be in the next video. So if you are liking this video, then subscribe to my YouTube channel, Taxonomy Online Mathematics, or follow me on TikTok as Sir Tazo, that is Sir_Tazo, TAXO. You can also follow me on Facebook as well, so that anytime I upload any video, you'll be the first to see. I'll be happy if you can share it with your colleagues, students, or those that will need this video. Thank you very much. See you in the next episode.